last video I have discussed about coronavirus meaning, name and morphology. In this episode we will discuss about replication, transmission and many more. Replication. Following the entry of this virus into the cell, the virus particle is uncoated and the RNA genome is deposited into the cytoplasm. The coronavirus RNA genome has a 5-methylated cap and a 3-polyadenylated tail. This allows the RNA to attach to ribosomes for translation. Coronaviruses also have a protein known as a replicase encoded in its genome, which allows the RNA viral genome to be transcribed into new RNA copies using the host cell's machinery. The replicase is the first protein to be made. Once the gene encoding the replicase is translated, the translation is stopped by a stop codon. This is known as a nested transcript. When the mRNA transcript only encodes one gene, it is monocistronic. A coronavirus non-structural protein provides extra fidelity to replication because it confers a proofreading function 9, which is lacking in RNA-dependent RNA polymerase enzymes alone. The RNA genome is replicated and a long polyprotein is formed, where all of the proteins are attached. Coronaviruses have a non-structural protein, a protease, which is able to separate the proteins in the chain. This is a form of genetic economy for the virus, allowing it to encode the greatest number of genes in a small number of nucleotides. 10. Transmission. Human-to-human transmission of coronaviruses is primarily thought to occur among close contacts via respiratory droplets generated by sneezing and coughing. Evolution. The most recent common ancestor of the coronavirus has been placed at 8000 BCE. 14, they may be considerably older than this. Another estimate places the most recent common ancestor, MRCA, of all coronaviruses around 8100 BCE. The MRCA of alpha coronavirus, beta coronavirus, gamma coronavirus, and delta coronavirus have been placed at about 2400 BCE, 3300 BCE, 2800 BCE and 3000 BCE, respectively. It appears that bats and birds, the warm-blooded flying vertebrates, are ideal hosts for the coronavirus gene source, with bats for alpha coronavirus and beta coronavirus, and birds for gamma coronavirus and delta coronavirus, to fuel coronavirus evolution and dissemination. 15. Bovine coronavirus and canine respiratory coronavirus diverged from a common ancestor in 1951. 16. Bovine coronavirus and human coronavirus OC43 diverged in 1899. Bovine coronavirus diverged from the equine coronavirus species at the end of the 18th century. Another estimate suggests that human coronavirus OC43 diverged from bovine coronavirus in 1890. 17. The MRCA of human coronavirus OC43 has been dated to the 1950s. 18. Middle East respiratory syndrome coronavirus, although related to several bat species, appears to have diverged from these several centuries ago. 19. The human coronavirus NL63 and a bat coronavirus shared an MRCA 563 to 822 years ago. 20. The most closely related bat coronavirus and the SARS coronavirus diverged in 1986. 21. A path of evolution of the SARS virus and keen relationship with bats have been proposed. 22-23. The authors suggest that the coronaviruses have been co-evolved with bats for a long time, and the ancestors of SARS virus first infected the species of the genus Hippozydeiridae, subsequently spread to species of the Rhinolophidae and then to civets, and finally to humans. Citation needed. alpaca coronavirus and human coronavirus 229E diverged before 1960. 24. So friends, in this video I have mentioned about replication, transmission, evolution. I will get back to you with new videos.
Press the bell icon on the YouTube app and never miss another update.